Alright guys, so all of what you see highlighted in pink, you're allowed to add to the back of your plate. I would try and keep it, if you fold your plate into 4, keep it inside one quadrant because we're going to have other stuff we add this chapter. But all of these are going to be things that you can plug into the Trig Identities that we're going to do today. So take a minute, pause the video, and you go ahead and write those in on the back of your plate. Alright, so this next section, you can't write this on the back of your plate. This is something I actually want you to know how to do. And actually, let me pause for a minute, I made a mistake. So now you'll see that I just changed that to even and odd because I had them switch. So remember, sine and tangent are odd functions and cosine is an even function, and the reciprocals share the same property. So this is what you're going to use if you see negative angles. So this is, again, we saw this last chapter. If you have negative angles, you have to think of what's going to happen to the equation when you plug in a negative angle. So when it's an odd function, it's always going to turn into the opposite. So sine negative x will turn into negative sine x. We can pull the negative kind of pulls out there because it's odd. It ends up being the opposite sign. But the goal is to not have a negative x, so you always want to rewrite these so you don't have a negative x in the angle, that either it's going to be the opposite sign, or if you remember for even functions like cosine, it's actually just going to be the same sign. So it's going to stay cosine x, and negative x is going to stay secant x. Those you cannot write on your plate. Those, again, I want you to memorize because you should know the difference between what it means when it's odd and what it means when it's even. Alright, so what we're trying to do is we're trying to prove trig identities. So what you're going to see is you're going to get an equation. Your goal is to get both sides to match. We do this by trying really to work only on one side of the equation. Work on one side, try to get it to match the other side. And when you're choosing, you want to choose the most complicated side. So if we look at number 1, so when you look at this first problem, the one that has the more complicated side is this left side. So we're going to be working on the left side. And then the strategy we're trying to use today, you're going to get a whole list of strategies as we work with these. The strategy we're working with right now is converting everything to sine and cosine. So if I focus in on this one, the first part is actually already sine, so I can leave it alone. But the second part, since it says secant, I want to change that to something that is in terms of cosine. And we know secant is the reciprocal of cosine, so it's going to change to 1 over cosine theta. And since that's a fraction, I would change sine to sine over 1 because we want them both to be fractions. So now we can multiply them together. And we get sine theta on the top over cosine theta on the bottom. Now you want to keep your goal in mind. Remember, the goal is to match the other side. The other side says tangent right now. And we just wrote sine over cosine. And if you look on your plate, there should be something we wrote down that you know sine over cosine equals. It's one of the quotient properties. Sine over cosine always equals tangent. So actually that side, we're still working on the left side, that's going to turn into just tangent theta. And it's going to match the right side, which is also tangent theta. So those are equal, and once you get the two sides to be equal, you know you're done. Check. We can move on to the next one. Alright, number 2. Again, the strategy we're working with is everything should either have a sine, cosine only in it. So tangent is the first thing we see. Tangent does not say sine or cosine, so we're going to change it into something that does say sine or cosine. Tangent is sine x over cosine x. Then we look at cosecant. That does not say sine or cosine, so we need to change that. That's really the reciprocal of sine, so it's 1 over sine x. And then the cosine x I can leave the same. The only thing I would do differently is I would write it over 1, so we have all fractions here. So now when you multiply fractions, if you don't remember, there's a rule here that says if you have things across from each other, they actually cancel out. So the sine x's are going to cancel, the cosine x's are going to cancel, and all we're going to be left with on that side is 1. 1 equals 1. That trig identity is done. So I changed it all to sine or cosine, and then saw what I could simplify, and this particular one, everything cancels. So you just are left with 1. Let's try another one. So on this next one, again, strategy. I want everything to say sine and cosine. None of this on the left side. The left side is the more complicated side, so that's the one I'm working on. None of this is sine and cosine, so all of it's getting changed to something. Tangent x is going to change to sine x over cosine x times cotangent x is going to change to, whoops, not what I meant to write. Cosine, cotangent, if you look on your plate, is cosine over sine. And now this is all over the bottom is cosecant x. Cosecant x is going to turn to 1 over sine x. So now this one, there is something you need to remember about how we actually multiply fractions together, or divide fractions. When you divide fractions, you actually need to change this. For dividing fractions, you have to change it to times the reciprocal. So what I need to do here, the top is going to stay the same. Sine x over cosine x times cosine x over sine x. And then the bottom is going to change to times. That's going to flip over times sine x over 1. And now I look and see what can cancel out. In this problem, the cosines cancel, the sines cancel. So all I'm left with is that 1 sine x. So I have sine x equal to, if you look back up at the goal was that it equals sine x. So we bring that down, sine x equals sine x. We got it to work. Alright, last one. And then we have one other strategy to talk about real quick. Again, goal is to get everything in terms of sine and cosine. So cosine x is already in terms of sine and cosine, so I don't need to do anything to that. That just says cosine theta. Cosecant x is going to have to change. Cosecant x is the reciprocal of sine, so that's going to change to 1 over sine theta. The minute that turns to a fraction, I'm going to put the cosine over 1. And that's all over. Tangent is going to change to sine theta over cosine theta. And this is similar to the last problem because we have a fraction being divided by a fraction. So that bottom one we want to change 2 times the reciprocal. So the whole top stays the same. Cosine theta over 1 times 1 over sine theta times, again the bottom we have to flip, so it's going to be cosine theta over sine theta. And then this one, nothing cancels out. So then we just want to start to combine. All the numerator gets multiplied together. So the numerator is cosine times cosine, which turns into cosine squared theta, over the bottom is 1 times sine times sine. Sine times sine is going to turn into sine squared theta. And then sometimes you got to go back, you got to look back at your goal. We're getting closer here. Our goal was cotangent. So I now see that on the left side we have a quotient, and we have a quotient property that tells me that cosine over sine is cotangent. So if cosine over sine is cotangent, then cosine squared over sine squared is just going to turn into cosine squared. So we are allowed to cotangent squared. We're allowed to change that to cotangent square theta. And then I can bring down the left side, which says the same thing. And I got them to be equal. So I am done. Alright, we got one more part to go. Alright, for this last one, we're dealing with our second identity idea, which helps you when you see negative angles. When you see negative angles, you have to use your even and odd functions. So that's what you have to remember. So the first part is cosecant negative x. Cosecant goes with sine, and sine is odd. So if it's an odd function, it's actually going to change the sign of cosecant. Cosecant is going to become negative, so that turns into negative cosecant x. And then we look at cosine. cosine is even. So since cosine's an even function, it actually doesn't change the sign, it just stays cosine x. So you need to think about whether they're even or odd and what's going to happen to the side. That only applies when they're negative angles, and you should always deal with the negative angles first. So if you see them in the problem, try and figure out what's going to happen to the side based on if they're even or odd. So always deal with negative angles first. So then from here, you're still trying to get them to match. So you're going to have to fall back on our other strategy. Our other strategy is to change everything to sine and cosine. So that cosecant is going to have to change into something that's in terms of sine. Cosecant is really 1 over sine x times, that's going to change to just cosine x over 1. And nothing cancels here, but I can combine them together, and I'm going to get negative cosine x over sine x, which again, that's a quotient, so if you look at the quotient properties you wrote down, cosine over sine is always cotangent. So that's negative cotangent x equal to, look what we were trying to get, negative cotangent x. They match, so you know you're done. Check. Hopefully this helps. If not, I will try and catch you guys up when you get back. Good luck.